Welcome to the Brownfields module Seta presentation. My name is Stephen Jason.
My name is Anemieke van Vieren.
My name is Danielle.
And my name is Nozuko.
Okay.
I will be doing section A, software development source files. Next slide. For questions 1, 2, 3, 4, and 5, we used multiple branches that each team member would work on, separated by features, which would then be merged back in. GitLab was used as source control, preventing loss of data for our project. On the screenshot on the right, you can see Git was used to push and pull updates on source files. On the left, you can see branches are merged into main once the feature is ready, and any merge conflicts were resolved locally or prevented by keeping local branches up to date daily. Next slide. You can see here on the left, Git allows multiple developers to work on the same project simultaneously. Git also keeps track of all changes made to the code. This allows the team to revert to a previous version if needed. And when multiple team members are working on the same piece of code, Git can help resolve conflicts by merging changes. Next slide. For section B, I will be doing code and design conformance. Next slide. For question 1, you can see here on the right, I've got our file structure, and on the left, we've got the requirements. We separated classes into packages based on functionality as per requirements, using persistence databases and separation of concerns. Next slide, please. For question 2, you can see that these two screenshots show us that data is being accessed from the SQL database using an API handler class as well as an interface. The API handler class is below and the interface is on the right. Next slide. For question 3, you can see here that names for functions describe the single functionality of it. Close server will close the server down, for example. Save world DB will save a world to the database. And for the final example, restore world DB will restore world from the database. Next slide. For questions 4 and 8, user stories were used to design our program based on how a user would interact with it. And then once then, tests were made from these user stories. Next slide. Following on from the previous, user stories were developed and then tests were built from them. On the right, you can see the need for an automated testing program was filled by building testing into the build process with the makefile shown there. The makefile assisted in removing the manual process of testing. Next slide. For question 6, there are tests for users, a reference server used in testing, and tests for the database, and tests are divided by iteration and appropriately tested according to the feature or code. Testing was done using the JUnit framework. Next slide. For questions 7 and 14, tests were run during the build process only allow successful builds. Any failing tests would be shown on the screen and the build would fail. Here you can see we're using the Surefire plugin to generate a bunch of test reports. And then on the right, the test will be based on what code we are testing. Here it is the robots that are specifically in their functionality which is being tested, and it's described with comments about what is happening within the test. Thank you. Next slide. For questions 9, 10, and 11, you can see 2 screenshots of our README file. In the README file are instructions for users to enable them to use our software, i.e. this project. On the right, you can see the screenshot of the README file continued. To minimize disruption to the user, instructions for installation and building are in the same README file. Okay, next slide. For questions B and 12, you can see here the layout of the project code was captured in UML designs, such as for the classes below. These class diagrams documented the structure of the project code and its components. Thank you. Those were my sections. I will now pass it on to the next section.
Okay, so I'll be doing section C, Database Management System, DBMS. Next slide, please. So in these slides, I will be describing database management issues and how it is addressed by DBMS, describe commonly implemented features of commercial database management systems, describe different types of DBMS, review DBMS end user tools. Next slide, please. What is database management system? Database management system facilitates storage, retrieval, and querying of data, acting as a bridge between users and databases, enabling them to manipulate data through operations like creation, reading, updating, and deletion. Next slide, please. Database management issues and how it is addressed by DBMS. Data backup and recovery. DBMS includes utilities for performing data backups, snapshots, and recovery operations to protect against data loss and system failures. It allows users to create backups of database and restore data to a previous state in case of disasters or errors. Data quality. DBMS offers tools for data validation, cleaning, profiling to improve the data quality. It allows users to define data validation rules and constraints to ensure that the data meets predefined quality standards. Data accessibility. DBMS provide features for indexing, querying, and retrieving data efficiently to enhance data accessibility. It supports indexing structures such as B trees and hash indexes to optimize data retrieval performance. Next slide, please. Commonly implemented features of commercial DBMS. Data Definition Language (DDL) enables users to define the structure of database scheme, including tables, views, indexes, and constraints. Data Manipulation Language (DML) provides the commands for querying and modifying data within the database, such as selection, insert, update, and delete statements. Cloud Integration offers offers features for deploying, managing, and scaling databases in cloud environments, as well as integration with cloud services and platforms. Features like automated provisioning, auto-scaling, and cloud storage integration are commonly supported. Next slide, please. Different types of DBMS. Relation DBMS (RDBMS) organizes data into tables with rows and columns, where relationships between tables are established using keys. Some examples are MySQL, PostgreSQL, Oracle database. Object-oriented DBMS or ODBMS store complex data types such as objects, classes, and methods directly in the database. They provide support for inheritance, encapsulation, polymorphism. Some examples are DB4O and ObjectsDB. Hierarchical DBMS organize data in a tree-like structure with parent-child relationship between records. Each child can have only one parent. An example is IMS, Information Management System. Network DBMS extends the hierarchical model by allowing records to have multiple parent and child records, creating a more flexible network-like structure. Examples are IBMS, Integrated Database Management System, and RDM. Next slide, please. Review DBMS end-user tools and motivate your choice of DBMS. Review DBMS end-user tools are MySQL, SQLite, Microsoft SQL Server, MongoDB. Motivate choices of DBMS. MySQL performance has a fast response time even with large datasets. Scalability easily scales easily scales to handle growing data and user loads. Reliability proven stability for mission critical workloads. Security robust encryption and access control features. Ease of use simple to install, configure, and manage. Community support community support, large community for resources and help, cost effectiveness, open source no licensing fees. Next slide, please. Project database code that facilitates the database connection and data sharing. These screenshots include the DBMS that we use with and it interacts with SQLite's database using JDBC Java database connectivity to create tables inserting data and retrieving data based on certain conditions. The Save to Database class manages the database connection, table creation, data insertion, and data retrieval operation. It includes SQL queries and perform these database operations, making it an integral part of DBMS application. Thank you. That is me. I'll hand it over to the next person.
Thank you so much, Nozuko. I'm going to now present section D. In our upcoming presentation, I've created a sequence of screenshots to demonstrate our process of updating our robot worlds. Following this, we assess whether users can successfully restore their world or if robot counts have exceeded limits, indicating the need to wait for the next game. Throughout this process, we constantly utilize JSON responses to ensure seamless data updates. Initially, we focus on managing data by either deleting or tallying counts of obstacle pits and mines. We optimize this data by centralizing it into a world table, which we later present to users for visibility in the world's composition. As you can see, we're using the product query and we're actually trying to save the world there. And if, for example, a user tries to use robot one and another user uses robot one again, it won't actually save it. And so they have to go and change it to like robot world 2 in order for them to actually join the game. In this example provided, we are using the one-to-many join sets to join our information together, which will be stored within our DBM. Right now, we are updating our tables using the delete table, and we are selecting the ID of each item, obstacle, pits, and mines. As you can see, we're using select and where, and that is essentially the many joining sets. So we are able to actually save our data with each other, and we are able to select with the ID or with the number one in order for us to actually edit it, delete it, or update it. For our next section, we also illustrate our connection to a Javelin server hosting a world API. We established this connection via port 6000 and defined server settings to retrieve world information in JSON format. We established a connection to the socket, confirmed the world's creation, and monitor players' connection. Additionally, we showcase the capability to delete and update information regarding pits, mines, and obstacles. As you can see with the screenshot that is provided, and we can see that we have the Javelin server as well. Now we're going to move forward. We configure essential world information like names, size, and elements, obstacle pits, and mines using a product query. An exception handler is implemented to verify the successful saving of the world. As you can see from our screenshots, we demonstrate our efforts to launch robots by connecting to an API and utilize JSON to display relevant information. We are using an exception handler to validate if a new player has joined and they are connected to their ports. We also check if a game is over, then we need to log an error message to let the user know that they can't join the game anymore. Here we are displaying information to the users so that they know the state of the world, and in the screenshot provided you can see how it would essentially be laid out and the sort of information that we're going to be giving to the users. They'll also be able to see whether or not they have a reload, how their health is like, and also see the dimensions and the visibility and whether or not they actually need to repair themselves along with distance. In the next screenshot, we can see that we're using the SQL select statement to obtain information about our robots, as well as the obstacle pits and mines within the robot worlds. Each naming convention is clear, and we can see we're targeting our robot worlds information, such as obstacle pits, with each select statement within the data access interface, basing it off of the whole multiples to select join that I mentioned earlier. In this screenshot, we are using an exception handler to validate our database connection, as you can see in the screenshot, database.db. To validate our database connection in the attached screenshot, we are comparing our parameters with the information provided to determine whether or not an invalid world has been supplied. Finally, in the last screenshot, we showcase commented code within the base interface, which is simplified interactions with the expected robot worlds API. This interface includes functions connecting, checking the connectivity status, and disconnecting from the server. You can see we've got the Boolean is connected and the void disconnect, just to ensure that the robots are actually connecting to the right port. And finally, I'm going to hand it over to Danielle, and she's going to take you through the next section. Thank you.
Okay, thank you very much, Annie. I'm going to be taking us through Section E, Assessing Test Plan Execution and Database Access Verification in Computer Program Testing. Basically, what I'm going to do is take you through all the tests for the project. Next slide. Okay, Section 1, showcasing the execution of operational steps identified in the test plan. So the test plan that we used for this project was from our curriculum. The curriculum came with a guideline and a whole bunch of requirements that when we were done with our program, the program was supposed to be able to simulate. So as an example, under Robot World client requirements in the curriculum, it was stipulated that looking around was supposed to be a functionality of a client or robot that entered the world. So was repairing itself, attacking, reloading, looking around, etc. And then with regards to the Robot World server, it was also supposed to have its separate set of requirements, including making sure the world was a grid, worked on a world coordinate system, directions, controlling the visibility of the robots, obstacles, pits, etc. And the way that we organize our tests were we organized them according to iteration and whether there were acceptance tests or not, and then every single file, every single functionality has its own test case to ensure that that functionality in the program is being executed. Next slide. Show the use of input data as specified in the test plan during the test. So with regards to this section over here, in the curriculum, we were given a whole bunch of stories and scenarios that we were supposed to follow, and a flow of exactly what our program was supposed to do and the requirements that were meant to be reached. I've got an example of a scenario here where a valid launch command should succeed. Now, the conditions of the scenario are as follows. Given that I'm connected to a Robot World server and the world is of size 1 by 1, when I send a valid launch request to the server, then I should get a valid response back from the server. The position of the robot should be 0 by 0 on the X and Y axis, and I should also be able to get the state of the robot. Now, directly to the right of that, you can see a screenshot of the test that makes sure that this functionality is actually carried through, test called valid launch should succeed, where we're asserting that the client is connected to the server, we're sending a string request of a robot called how, and we're sending it with a launch command, putting it into the world. And then we're asserting that the result we get back from the server is not null, therefore we get a valid response back. And then we're doing things like checking the position of the robot, making sure that it is where it's supposed to be through assertions. Next slide. Another example of this is the second scenario where we should not be able to move forward if we are at the edge of the world. And these conditions being, given that I'm connected to a Robot World server and in a world that is 3 by 3 in size, I try to move forward by 5, then I should get a message informing me that I am at the edge of the world. It should specify which edge I am currently at, and the position of the robot should not change. And here in the test, we have a test case testing that specific functionality called at the edge of the world, where the first request we're sending is we're launching the robot HAL into the world, and then the second request that we're sending is we're asking this robot to move forward by 5 steps in this world that is 3 by 3, and then we're validating the response we get back from the server, being we are supposed to be at the north edge, and then our robot's position should not have changed in the assert equals. So we're testing what we know the output should be against what the output actually is. Next slide. So outlining deviations from the test plan with explanations during the testing. As much as me and my team didn't necessarily deviate from the test plan, we definitely added additional test cases. So one thing that our project did have was we had multiple different kinds of robots that you could select from, ranging from the machine gun robot to the normal robot, the sniper robot, and the tank robot. And because these were additional features that were added, they weren't necessarily in the test plan. So instead of deviating from the test plan, we added features to it to make sure that we were testing everything as a whole. We've got a test called execute normal robot, testing the functionalities of the normal robot, execute machine gun robot, and execute sniper robot, making sure that these robots or these additional implementations are also accounted for in testing and work according to the program. Next slide. Follow the standards and procedures specified in the test plan for testing and retesting. So during the development process, testing and retesting is an absolute necessity, where every time we add a functionality or change a piece of code, we have to make sure everything else is still in order. And the way to assert that we're making sure that all the tests are run under this a controlled environment, we set up and tear down functions, where in the beginning, before any tests were run, we're establishing a connection to the server. and then we're running all of the tests in that simulation, that specific simulation. Every single test case has a constant variables that were set up in the beginning instead of connecting and reconnecting after every single test case. And then after each test is run, we're disconnecting from the server. It's getting rid of all connections getting rid of the first connection that was established instead of having to go through and disconnect every single connection that was made before each additional test case. Next slide. Show the testing of our code's logic paths. So the best way to test the code's logic paths is to simulate an actual round of the Robot Worlds game where we're giving multiple commands to the server and we're expecting multiple different kinds of responses. So in this situation, what we're doing is we're testing a fire command. And in order to execute this, we have to launch a robot into the world first. The robots have to be able to move around. One of the robots have to be able to attack. So we've curated this in a list of steps where 1, we're creating a list to store the robots. 2, we're creating a new world as if the world was created during the simulation of the game itself. 3, we're creating a normal robot and adding it to our world, validating that we can launch a robot. Then we're creating a second robot and adding it to a world, validating that we can have multiple robots in the world. And then we're changing the current position of our second robot by moving it forward, testing the direction and the moving capabilities of the clients, and then instructing the first robot to shoot. Now over here we're testing the fire command that we've implemented. And then lastly, we're asserting that all the responses we get after all of these commands have been sent match what we're actually expecting to get back from the server. And over here, as you can see on the left side, we have an assert equals with all the information that we were expecting to receive back, and we're asserting it or testing that it is equal to what we've actually gotten back from the server itself. Next slide. Okay, showcase the elimination of errors identified through the testing of database access using SQL. So errors during programming are a given, and we have to make sure that we can handle these errors within our code so that our program is not actually crashing during the simulation of the actual game or during the execution of the program, where we can catch problems that might potentially happen and then divert the program and make it do something else instead of crashing completely without anybody knowing why. So over here we have our get database to use function over here, where we have multiple if statements, making sure that if we run into a certain issue, we can redivert and use a different path instead. We're also throwing, or we're using try catch blocks to make sure that when an SQL error, for example, is thrown, we can catch it and then we can do something about it instead of the program crashing. Next slide. Verify through testing that database access functions are in the required environment, performs, and functions according to requirements. So just like how I spoke about before, we have a get database to use function where we're actually accessing the database, and then we're also accessing or we're making a connection to the server, and I'm calling those functions here in the successfully save a world test case to make sure that this functionality can actually be carried out without it crashing, and ensuring that once a world is actually saved, it'll be saved, and if there was an error that was thrown, our program can redivert accordingly, instead of just failing or instead of just crashing. Next slide. Show all records for tests executed during the testing of a computer program. So after running all of our tests, including the acceptance tests that were written, every test for the different iterations that we had to enter, and then lastly the functionality tests of the robots being able to attack, shoot, shield and shoot. When we run all of these tests, this is a screenshot of the terminal and the results that we get after running these tests, where we can see that the build was run successfully. 58 tests were run in total, 0 failed, there were no errors, and none of them were skipped. This verifying that the program that we have created and all the tests that verify that all of those functionalities are being met actually pass and our program is acting the right way. Next slide. identify variations from expected results from testing your code and give reasons where available. So during testing, again, we're going to test and we're going to retest. So what we did here to make sure that we could keep track of all of this and then analyze it afterwards was we used the Surefire plugin because we were using Maven testing. So Surefire reports are generated by the Surefire plugin, which is used in Maven-based projects for running unit tests. And these reports provide detailed information about the test execution results, helping us understand the outcome of our tests. It also helps us identify results, including the total number of tests executed, the number of successful ones, failed tests, and skip tests. It gives us a nice little summary where we can always revert back to and look at and analyze to make sure that everything is working accordingly. Next slide. Okay, evaluating documentation consistency and design adherence in computer program presentations. Next slide. So one thing that me and my team were very adamant about was documentation. Documentation is very important for multiple reasons, including if somebody else wants to come in and read your code, they need to be able to understand what functions are doing. And then it also helps as a guideline for the developer themselves to understand that the code or the piece of code they're writing, what exactly its functionality is and what it's supposed to be returning. These are multiple screenshots from our program itself where we show thorough documentation stating what a function is returning, stating what response we're expecting, stating exactly what a function's purpose is and the kind of functionality that it's actually implementing, just for consistency and because it is a group project and when everyone comes and reads the same code, we have to actually understand what's going on. So documentation was thoroughly done through all the different files and yeah, documentation was done. Okay, and then that'll be me. Thank you.
Thank you so much. Okay, so that's going to wrap up our presentation and for Brownfields, and thank you so much for being a part of our journey.